So the question we are about to work out now is not an easy question. It is a Euclidean geometry grade 12 proportionality theorem question, and I guess by right angles. Nice to meet you. If we have never met before, what's up? On this channel, we basically go through like math tutorials, mainly for grade 12 learners, but I mean, you know, sometimes we do like try to take things a bit lower. But let me not waste anybody's time. We have worked on these two questions already. I'm like, if you need access to those videos, the links to that is in the description. But anyways, they want us to prove that AE, which is this random line over there, is equal to AD, which is that random line there, multiplied by AC under square root. I don't want to lie, this is not like an easy question per se, but it's not difficult either, because when you need to prove questions like these, it's all about the proportionality theorem. And the proportionality theorem is all about identifying triangles that you need to like work with, and those triangles you need to prove that they are similar first, and then the rest is just gonna be pop and place. Whew, if you like pop and place, what's up? But anyways, so this is the idea, right? Depending on the lines that they're talking about, you need to identify which triangles are those lines in. I'll repeat. They're speaking of line AE here. AE is this line over there. So let's just draw it out. There's AE there. There's A there. There's E there. And then they spoke of AD. So AD goes from A to D there. And then they spoke of AC. AC is literally from here until there. They see over there. Now, looking at these three lines here, or the three lines that they spoke of, this is what you want to do for yourself. Firstly, AE and AD, right, are two lines that they spoke about. You want to think to yourself which triangle can be formed just by looking at those two lines. And the triangle that can be formed is this one, triangle ADE. That's the first triangle you have spotted, right, from the lines they're talking about. Now, obviously, we need another triangle. And thinking of the lines that they spoke of AE, they spoke of AD, we already used those two. But then the other thing now is they spoke of AC. Now, looking at where AC is, I mean, like you want to ask yourself, if you think of AC and any of the lines that they spoke of, which kind of a triangle can we draw, or what triangle can we draw? And the basic one is this one. You see ACE there. From the line AC that they spoke of and from the line AE that they spoke of, we are able to draw two triangles. The two triangles that we have there is AED and ACE. Those are the two triangles we're going to work with. Now, the idea with us working with these two triangles is that we're going to have to prove that these two triangles are similar to each other. Now, proving that these two triangles are similar to each other, I mean, we don't have to crack our brains while doing it. We just have to be strategic as well. So when I say we have to be strategic, what I mean is, if you look at the way our sketch is lined up, right? The way our sketch is lined up, I think the easiest words to use there is the way our sketches are lined. Not the way the sketch is lined up, but I think you get the idea. So looking at the way this sketch is like set up, you want to keep in mind that, okay, fine. I mean, if you're going to prove that angles in these two triangles are equal to each other, I mean, the easiest one to firstly work with is A, because A is in both triangles. A is in the small triangle over there, and then A is in the big one. So we might as well just show that those two are equal to each other. But then before I even carry on, I mentioned that we're working in triangle ADE, and we're working in triangle, let's see, this one, I mean, like, since A is equal to A, we might as well start the name off with an A. Now here you can play the guessing game, you know, in quotation marks. What I mean by playing the guessing game is, I mean, we can automatically almost guess that the E here is going to be equal to the C there, because they kind of look like they're going to be equal to each other, you see. So when we see the E for the one triangle, we might as well put a C for the other one, you see. So meaning that this one we can name it A, E, C, like that, you see. Because just from our intuition, we already know that A there is going to be equal to the A there. The E here for this triangle is equal to the C over there. So where the E is, we put the C there, and then whatever is in the middle is like the third. angle that is left there. So we're working with these two triangles, and our job is to just show that they are similar. And the easiest way to prove that triangles are similar is to just find two angles that are equal to each other, or two pairs of angles that are equal to each other, and then the third pair will automatically be equal to each other because of interior angles of a triangle. But anyways, let us not waste anybody's time. Let us find those angles that are equal to each other. So from what we said, we know that A2 is equal to A2. That's a common angle. Now, you may be thinking to yourself, yes, we did say that C here is equal to the E over there. We don't have to find a reason specifically. You know, we could work with angles that are easier to like show they're equal. Or rather, I mean, if you can remember, we already proved that the E over here, which is E2, is equal to the D over here, which is D2. We've proven it already. So we might as well just go ahead and use that reason, right? The reason is proven. We know that the E here is equal to the D there because that has been proven. So therefore, I mean, as a conclusion, not a conclusion per se, but from there we can now just say that the E here, which is going to be DEA, is equal to the C here, which we can just call ECA. The reason that those are equal is just interior angles of a triangle, because we have shown that at least we've shown that two pairs of angles are equal, so the third ones are automatically equal to each other. Like, yeah. Anyways, so because these are all equal, we know that we've proven that these two triangles are similar to each other. So here we have written that those two triangles are similar because we have shown that three angles are equal to each other. And that's how we are about to end up with this expression over there. Because as long as you can end up with this, you're almost like 60% done with your question, maybe even 70. So since we've proven that these are similar, we're able to now write out a few proportionality expressions, you see. Now from what we have written out, we can easily write something like AD over AE is equal to DE over EC, which is also equal to AE over AC. The reason for writing all this is just the proportionality theorem. Now you need to be very careful. You can only do what we have done here if you have made sure that your angles here are aligned with the angles there. Meaning that the A here has to match with the A there. The D here has to match with the E there. The E there has to match with the C there. Meaning that the angles have to be the ones that are equal to each other. Otherwise, you cannot write this out and it being accurate. So that's why sometimes when people have proven similarity and they try to do this, it doesn't work out because your angles will be like mumbo jumbo. You see, so that's why you need to be very careful how you like name your triangles. Always name them according to the angles that are equal to each other, you know. So with all that we have written out here, we want to end up with an expression like this one. So the easiest way to do that is you want to pick out two ratios or two fractions that at least have these lines in there. So obviously we need AE. Two of them have AE, which is perfect. And then we need AD. This has AD. We need AC. This is AC. Voila. We're going to take these two. And then from there, for us to end up with like an expression where there are no fractions, it looks like we can just cross multiply. So cross multiplying AE times the AE there, it's going to give us AE squared. And then AD times the AC there is just AD times AC. And obviously for us to end up with like a square root, I'm like, hello, we're just going to square root both sides. And then AE is going to be on its own here. And then this side, we're going to have AD dot AC. Wait a minute, I remember in the beginning I started with, what did I say? I think this question is difficult. Oops. I think now that we've like gone through it, there's really not much to it, hey? Like, dang it. There's really not much to it, like, seriously. But anyways, that's the idea with these kinds of questions. Now, as I mentioned in the previous video, if you didn't watch the previous video, I might as well just give you a reminder of like what we spoke about in that video. It's this, our recommended study guide. So, if you've had me talk about the study guide and you haven't bought yet, and you're in grade 12, it is what it is. But anyways, this is our recommended study guide, The big idea with this study guide is that it basically goes through grade 10 work, 11 work, and the grade 12 work. So obviously with like Euclidean geometry, you can imagine this is gonna go through like the theorems first, and then after going through the theorems, it's gonna go through the proportionality theorem, which is like the new grade 12 hard stuff. Now, obviously, like the reason why we recommend the study guide is because it's not like a summary or whatever. No, no, no. It's gonna take you through all the stuff. Now, this paired with our online courses, it's almost, I would want to say that if you do put in the work and you go through all the courses and you like use the study guide, I mean, like one or the other, there's no way you're not gonna get a distinction. Like, it's just that simple. So there are two ways to get the study guide. I mean, like you can get it on our website. You can just buy it directly on our website, and shipping is like 100% free. The other way you can get the study guide is if you sign up for the all access pass once off for the year. Meaning, if you sign up for the year once off, then we shall send this to your address for free. And then, yeah, you can also start getting distinctions. I mean, I wouldn't be telling you about this study guide if I was not like using it myself. I mean, this question came straight from the study guide. Let me see which page it was on. Give me 2 seconds. Give me 2 seconds. Voila. If you look nicely, I think I'm gonna zoom in. Obviously, see, it's the exact same question. Now, these kinds of good questions, yeah, you obviously do want a good study guide. But anyways, for now, I shall catch you in the next video. Don't forget to like, subscribe, and or don't forget to plug your friends, because you don't want to be that guy, just passing along. Hey, your friends are failing. Like, why? Why you gotta do that? It's not fair. But anyways, if you need like full past papers or full videos of me going through full past papers from like start to finish without leaving anything out, that is on the second channel, which is called Metric Math Past Papers. And then, if you need something extra, like all the Zoom sessions that we have, right? Like they're all recorded, obviously, and then that is also uploaded on like a third YouTube channel. It's just so that there isn't like too much of a mess, just everything on one channel. Nah. We like to, keep things neat and all that changes. But anyways, if you need that, the links is in the description. In the description, there's like a bunch of links actually. You'll find a lot of good stuff in there. So yeah, that's that. I will catch you in the next video.